Hi colleagues, good morning everyone. Beautiful morning at the start of the day. For those of you who are watching this video, this time we will discuss quite interesting material. A slide wire generator. We start from a system consisting of a U-shaped conducting wire lying in the XY plane. A straight wire was inserted between his legs. Conductor wire and straight wire form a closed area. We can call the line enclosing this area a closed loop. This wire can be shifted to the right and left. That's why we can call this wire as the sliding wire. Let's just say there is an external magnetic field towards the negative z-axis, or into the xy plane. We can represent the magnetic field as a cross. Now the sliding wire moves to the right, or towards the positive x-axis. Pay attention to the area between the conductor wire and the sliding wire. The number of magnetic field lines that penetrate the closed loop increases. The number of force lines increases as the sliding wire moves. Based on Lenz's law, an induced magnetic field will be formed. The direction of the induced magnetic field is out of the plane, or towards the positive z-axis. To produce such an induced magnetic field, an induced electric current must flow through the loop. The flow of the induced current is counterclockwise as seen in the picture. Electric current will flow when there is a voltage difference. Electrical voltage that previously did not exist becomes present. This voltage is known as the induced EMF. This voltage was studied by Faraday. So, we can apply Faraday's law in this case. Let's just write Faraday's law as epsilon equals minus big N d phi dt. In simple language, EMF voltage will appear when there is a change in magnetic flux. In fact, magnetic flux itself is influenced by three quantities, namely, B, A, and cosine of beta. In a slide wire generator, the magnitude of the magnetic induction and the angle between the magnetic field and the surface normal are fixed. We can exclude the value of B and cosine beta of d dt. A closed loop has a shape similar to a rectangle. Let the length of the slide wire be L, and the width of the rectangle be x. Then the area of the closed loop, A, is equal to xl. If the sliding wire moves, it is clearly seen that the value of L is fixed. The only value that changes is the length of x. So, I can also be excluded from the calculation of d dt. If we still remember, the change in horizontal displacement with time is velocity. Dx dt is nothing but v, or the velocity of the sliding wire itself. In this case, the wire that forms the loop is only one layer. The big N value is 1. Beta is the angle formed by the normal vector and the external magnetic field. Beta is 180 degrees. The cosine of 180 degrees is minus 1. So, the EMF voltage value is BLV. The epsilon value is positive, meaning that the induced current will flow counterclockwise according to the illustration. Hopefully the tutorial is useful. And, don't forget to watch the next video.
I am waiting for a bus at the end of the night.